Question 1a. The reaction of zinc with sulfuric acid, H2SO4, AQ, is shown. Zinc is a solid metal, reacts with H2SO4, AQ, which is an aqueous solution, to produce a solution of zinc sulfate plus hydrogen gas. All right, so the hydrogen gas is produced in this reaction. State the test, including the result for hydrogen gas. Well, we burn it, and the result is a popping sound. So burns with a popping sound. All right, that's going to give us our first answer. Burns with a popping sound. The student was asked to draw a diagram of the apparatus used to collect and measure the volume of hydrogen gas produced during the reaction. Their diagram is shown. Okay. Describe one way in which the student's diagram is incorrect. Well, there's a few things that spring out immediately. First of all, there's no bung in this flask, which means the gas can just disappear up here and won't go into this tube. The other thing is the collecting tube is closed at the end, so we could say that. So there's no bung in the flask, the reaction flask. There's no opening in the end of the collecting tube. And the measuring cylinder is not graduated. You could put, there's no scale on the measuring cylinder. And there may be others, but I'm going to go for the obvious one. I mean, there's nothing that's going to be collected at all. These bubbles won't come out unless there's a bung on the... So, no bung on the reaction flask. The collecting tube is closed. There's no scale on the measuring cylinder. What else? I mean, you don't technically need a scale on the measuring cylinder, because as long as you mark up with a pen, you can fill it up and measure off the water with another measuring cylinder. But I suppose. So let's see. Solution of zinc 2 sulfate. ZnSO4AQ is produced in this reaction. Name the technique that could be used to obtain a dry sample of zinc 2 sulfate ZnSO4 solid. Well, from what we see here, it's a soluble substance. It's a soluble salt, so it dissolves in the water. So what we'd have to do first of all is evaporate it to dryness. We would probably want to filter it off any remaining zinc powder. Doesn't tell us whether the zinc was present in excess, but if I've got my zinc sulfate in here in this mixture, in this solution, and any zinc is left over after the hydrogen is all reacted, the thing I want to do is I want to remove the zinc. So I'm going to filtration and evaporation to dryness will get me the zinc sulfate solution. All right. Question 1b. 1b. The volume of hydrogen gas collected over time when zinc powder is added to 100 centimeter cubes of dilute sulfuric acid was recorded. Graph of the results is shown. Here's the result. Calculate the average rate in centimeters cubed per second for the first 50 seconds. Show you're working clearly. Okay, so what do we want to do here? Well, we're going to use, and the reaction is in, the calculation, the relationship is in the data book. So we're going to use this one here. Average rate equals delta quantity over delta time, the change in quantity over the change in time. So average rate equals delta Q over delta time, right? Delta time. Right, good. So what we need to do is figure out what the delta quantity is. Delta time is 50 seconds, so delta T equals 50 seconds. Delta quantity equals what? Okay, so we have to look here. So 50 seconds is there. So what does that look like? That looks like 87 centimeter cubed from 0. So I'm going to go 87 centimetre cubed. So that means that my calculation is going to be 87 over 50. And that's going to equal my rate. Let's get my calculator out. 87, not 85. Let's get that right. Make sure you don't make those sort of mistakes because it's very easy to just put the wrong number in. So 87 divided by 50 equals 1.74 centimetres cubed per second. That looks like a 7. We'll just make it look like a 1. Right. So 1.74 centimetre cubed per second. So next we want to add a curve to show the results that would be expected if the experiment was repeated using the same mass of zinc lumps. All right. So we're using the same mass of zinc, so the product volume will be the same, right? We're going to get up to here, but because it's they're zinc lumps, it's a larger, smaller surface area exposed to the reaction is going to go slower. So what we're going to do is we're going to put in a line that is a slower rate, but comes up to the same level. So I'm going to put in something like that. And that should get us the mark. Add a curve to the graph. And there's the curve. You don't have to label it, just stick it in there and they'll see that. Okay. A similar experiment was carried out using the same mass of zinc powder and the same volume and concentration of hydrochloric acid, HClAQ, in place of sulfuric acid, H2SO4. Predict the volume of gas in centimetres cubed produced in this reaction. Okay, well, if you use the same volume and concentration of hydrochloric acid, you're going to only get 1 hydrogen ion per unit of concentration compared to 2 hydrogen ions per unit of concentration with H2SO4. You only get 1 for hydrochloric acid, you get 2 for H2SO4. So this is what we call a monoprotic acid. This is called a diprotic acid because it's got 2 hydrogen ions. So basically, if we don't double the concentration of hydrochloric acid, we're going to end up with half the amount of H2SO4, half the amount of hydrogen from that. So basically what we need to do is say, what's the total amount? It's 96, so it's going to be 96 centimetre cubed over 2 is going to equal 48 centimetre cubed. And that's going to be our answer, 48. Make sure you draw it. You don't want to give them any excuse to knock you down a mark, although they do mark. The point is that they will mark you as generously as possible. All right, there you go. That's the end of question number 1. Hope you enjoyed it. See you in the next video.